Well, good afternoon. Well, my name is Alejandro Costa. I'm going to talk to you about a project that in LACNIC we feel something like proud about this. Basically, it's identifying DNS open resolvers, as you can see in the title, which is quite specific. Well, as all of you know, to identify DNS open resolvers in the IPv4 world is quite easy because the IPv4 address space is not that big. In IPv6, it is more difficult, and we needed to take a different path. So, what we did? Basically, we are taking, with a very specific TCP/DOM command, we're creating a pickup file in a root server. Actually, this is a reverse DNS root server. It is not the root server that traditionally we listen, but it is somehow a server that receives a lot of queries. The queries that are getting that we can identify in step one, we can safely assume that are recursive servers in the internet. So what are we doing after that? After we have the pickup file, we process it, we work with it. We are using PyChark to do this. We remove in somehow duplicates and IPv6 addresses and so on. Then, after we have the IPv6 address identified, which we know that it is a recursive DNS server, we perform a very simple query trying to see if that IPv6 address allows recursion. Okay? This is actually the way that we identify IPv6 addresses. I am doing some emphasis here because traditionally when we present and we show this project, the main question that we receive is how do you identify the IPv6 address? There are many other ways of doing this. And well, finally, the last step, of course, is processing the data, showing results, publishing, and so on. I'm going to skip this slide since the results, I'm going to show most of this. Okay, there is a summary. Maybe this slide is interesting. You can see by RIR the total of IPv6 DNS server that we have identified. For ARI, let's talk only about the first line, we have identified almost 2,000 IPv6 DNS servers. What we did, we ran a simple query to all of them, and we were able to get 51 open resolvers. Okay, as all of you know, maybe this is not the expected behavior. Most of the time, open resolvers are not good in internet. Of course, we know that some providers in somehow have DNS recursion enabled to everybody, like Google and many more. So what else? This is more or less the same information that that was shown in the table. Let's talk one more time about ARIN, since we're in ARIN region. In the most left bar chart, you can see in the blue line the total number of servers that we have found, and the orange line more or less shows the DNS that were open in somehow. Okay, it is allow recursion. This graph, it is only for LACNIC region. Sorry for that. I did this slide last night. Since we are getting data since March of this year, we were able to create a timetable. However, we can do this for any RIR and for any country, actually, that we wish. Basically, you can see that on the first graph, the amount of open DNS resolvers, IPv6, that we have found in our region, in LACNIC. And in the second graph, you can see the evolution of the non-open DNS servers that we have found. Later, you can see that Brazil, they have the most amount of DNS servers, and the same case for open resolvers in IPv6. And we have found something that is interesting, at least from my point of view. We have identified that certain /64 prefixes there are a lot of resolvers in each. For example, in the first line, we found 62 servers in only one /64 IPv6 prefix. We believe that this is because of the privacy addressing that some operating systems have implemented. But this is, from my point of view, this is quite interesting too. What were we looking for? This is type of results that we have. You can see at least yesterday I did this, a couple of ARIN results from Canada and from the US. I only took servers that we were able to find that were closed. On the very right, just on the left of ARIN, we were able to get the owner ID of that IPv6 address. So after that, we're able to contact the owner of that IPv6 address and tell him or tell them, sir, you have an IPv6 open resolver, please take care of that. And this is an example of what LACNIC members, only LACNIC members, are receiving in this moment. This is an email that we started sending about 6 weeks ago. You can see that every Monday, you can see something like, dear member name, you appear to be running a DNS open recursive resolver at IP address, blah, 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 blah. It explains what it is. There are 2 examples in how to fix this for bind and unbound. And I'm happy to tell you that we have already got evidence of people that receive our email and fix their server. Actually, we have a very nice example. Last week, one member of LACNIC received the previous email. He had 2 servers. Of course, we only found one of them, and the member fixed the 2 servers that they have. So it is a very interesting example that now we were able to do this, and we are very happy. We are not sending the email to other regions, for RIPE, Afrinic, or any other one. If you wish to contact us in somehow to go in detail how we are doing this, please feel free to contact me. Our next steps is integration with some LACNIC systems, when the user enters username and password, automation of some statistics, publishing open data. And something that we think could be quite interesting is trying to find out if some of the DNS servers that we were able to find probably are in squat prefixes, prefixes that has not been assigned by any RIR or IANA even. And that's all what I have. I don't know if there are time for questions. Oh, hello.
Good? Okay. Wes George with ByteGrid. I'm curious, did you see any 64 addresses in the analysis you did?
64 addresses? You mean map ID addresses?
Like 2002::/16.
Ooh, actually, that's a terrific question. Unfortunately, I did not pay attention to that, but I still have the data. So, I'm going to do it now that you mentioned that.
I might suggest that you look at that because I was analyzing earlier this year, I was analyzing a V6 DNS dictionary attack for a large DNS provider. And out of, let's see, out of the 400 or so open resolvers that I found out of the list of querying hosts that were participating in that dictionary attack, more than half of them were from 6-4 space. And I couldn't really determine whether that was some sort of weird vagary where, because there was a 6-4 functional address, the DNS server was just doing that because it was configured and it was using whatever available interfaces, or if there was some sort of an explicit effort there, or if this was more, the 2 were unrelated. Like you had a v4 open resolver that also had a 6-4 address and was talking via that interface. But there's probably some analysis to be done there, because one of the questions that might come out of this is it time to just start configuring authoritative and recursive DNS servers to reject queries from 2002::/16 as sort of overtaken by events and no longer useful, and thus just closing down an attack vector? I don't really have a good answer to that, but that's the question raised in my analysis.
Well, terrific, interesting. Believe me, I'm going to my computer, and I will try to find the list of IPv6 addresses regarding that 624 transition mechanism.
And if you want to see the data on mine, if you go to iepg.org, it's in the March 2018 presentations.
Okay, let's talk about that later. Thank you. Bye.